Awesome. Okay, great. So I'm actually kind of curious. There's a bunch of you on here. I'm assuming most of you came because you're interested in electrification. Kind of curious, what was there? A bunch of you thinking about actually implementing electrification? Are you more interested in general about, what it looks like in the future? Like, what made you interested in today's topic?
Future.
The future. That makes sense. Anybody else?
So I went to the Better Building Summit last April, and I had attended that summit in the past for many years when I worked in hospitality, but now I'm in multifamily.
Yep.
And the focus always had been efficiency, water, energy, so forth. But now the focus has really shifted, seems to electrification, decarbonization. And what we're seeing in certain markets where we operate, especially DC, with the DC BEPS requirements, it's hard to meet those building performance standards unless you do electrify. And they had a lot of sessions on electric heat pumps. It seemed like heat pumps was the solution to everything. So I'm just trying to learn more about it. We operate a little over 300 properties, and so each year we submit capital budget requests to our clients. And so when it comes time to replace gas-fired heating boilers or water heaters, we need to start thinking about, should we be trying to convert some of those over to electric rather than putting in gas for the next 15 years and then kind of being stuck with that decision.
Yep. I'm really glad you shared that, because I think that's on a lot of people's mind. You mentioned a few different things that I think are really relevant, which is, one, there's a compliance issue, right? I mean, most cities from DC, local law 97 in New York, Berto in Massachusetts, there's a lot of pressure to reduce carbon. Electrification is one of the paths to do that. And also just generally there are capital repairs happening, right? And it's like, am I going to invest in gas again, or do I move to electrification? So these are great questions. We hear this all the time. That's why we're doing today's session. I'm going to start with just some basics to make sure everybody's on the same page. Is there anybody who doesn't know what building electrification means, like what it refers to?
Not completely.
Okay. All right. So generally, I mean, it can mean a lot of different things, but generally when people are talking about electrification for buildings, what they mean is generally moving towards electric for heating and cooling if it's not, excuse me, if it's not already on electric. And the biggest source of that is obviously a heating boiler, right? There are many buildings that use absorbers for steam or for cooling as well. But the vast majority of buildings we're talking about really heating electrification. And what people are referring to is generally replacing a gas or oil-fired boiler with heat pumps. And those come in a couple different forms. So I'm going to run through those. But before I do, I just want to explain how a heat pump works, just so everybody knows. Let me share this image here so I can do a little drawing. I apologize in advance. You're all going to have to tolerate my horrible drawings. But this is a old school window AC, right? If you've ever walked by the outside of a window AC, right, it's blowing hot air out. The way an AC works to cool is it's hot out here. So this is the outside right here out, and this is the inside, right? And I'm going to talk about an AC, but I'm going to talk about a heat pump in a second. The way that a AC works is there's a lot of heat inside, and it's taking the heat and it's using an electric process to move that heat outside. So that's why when you walk by the outside of an AC, you'll feel heat being blown out. The way that a heat pump works is literally in reverse. And in fact, most now ACs have essentially a mode that lets you just reverse the system and it will blow heat in instead of out. So this is AC. And this is how a heat pump works. And what it does is even though, let's say it's like 40 degrees outside and it's 70 degrees inside, there's still heat outside that you can move inside. And that's what the heat pump is essentially doing. It's just reversing the AC to bring heat from the outside inside. The reason that this is really like an amazing thing and people push it on the climate angle is that you're not doing any combustion. So when you don't have to combust some kind of fuel, either an oil or gas, you get a much more efficient system. So ACs are generally pretty efficient, and heat pumps, these are called air source because they're using air to move heat, are generally pretty efficient above essentially about 30 something degrees, let's say about 32 degrees. Anybody want to take a guess why when you get down into like the 10 degrees or 15 degrees or even lower, air source heat pumps become really inefficient?
There's just not enough warm air to get out of that kind of air.
Correct. So that's exactly right, Phil. So it's freezing outside, it's 0 degrees out. There is heat in that air, right? It's not 0 degrees Kelvin, right? But there's very little heat. And so it takes, as the temperature goes down, the heat pump has to work harder and harder and use more and more electricity to move that heat inside. So this is why when you go to, I'm actually in Florida right now, when you go to Florida, Texas, a lot of the South, you see a lot of heat pumps because it's very easy when it's 50 degrees out or 55 degrees out or 60 degrees out to move heat indoors, and it's very energy efficient. You see very few gas-fired boilers in Florida, right? And that's really how things have historically worked. In New York and DC, DC is sort of on the fringe, but New York, Boston, Canada, very expensive to run heat pumps. And that's why you haven't seen as much adoption and why most buildings, particularly when fossil fuels were cheaper, are really designed around gas and oil burning burners and boilers because it's just a lot cheaper and more economically efficient. The other challenge here is that as you get, even if you want to talk about pure energy efficiency, the other problem with air source heat pumps is that the electricity that you're using to power that air source heat pump is usually made either with coal or increasingly with gas, which means you're burning a fossil fuel. And because you have to go from fossil fuel to electric and then transport that electric over long distances, you end up with a net fossil fuel that's way worse than just burning the gas on site and running your boiler. So these are the challenges. The good news is that heat pumps have become a lot more efficient over the last 15, 20 years, but not really enough to overcome this cost differential. And I sort of want to show, I'm going to share this here. We did some math on what not forgetting the upfront costs. We're talking about just the ongoing costs. So if you were to take a building, and we did it by unit size, 25 units, 50 units, 75 units, 100 units, forgetting the one-time cost, which is pretty significant, of replacing the system with heat pumps, this is just the ongoing cost afterwards. And as you can see, in a gas building, pretty much no matter what the size is, you're seeing a pretty dramatic increase in the cost of running heating by moving to air source heat pumps. So this is, and oil is a little bit better. You'll see in smaller buildings, it's okay. In bigger buildings, it gets better. The challenge is then when you factor in the one-time cost, it becomes extremely expensive to, Phil, I'm just going to mute you. Yeah, thank you. It becomes the payback cost could be 20 years to replace it with air source heat pumps. So this is a major challenge, and it's a reason that you're not seeing a huge amount of adoption in heat pumps in retrofits. What you are seeing, and this is very, very common, is new construction is being built with heat pumps. Number one, first of all, the city's banned new gas hookups and essentially telling you can't really use oil. Like you can, but you know that that's going away. So what new construction does is, and I'm going to go back to my diagram here. Oops, sorry. Going back to my drawing here. So this is an air source heat pump. What it means is we're trying to take heat out of air. So when there's another alternative to this, which is what's called a water source heat pump. And you can look at this as a pipe. Here's a pipe filled with water, right? And there's some kind of device that attaches to the pipe. This pipe here is usually just kept at about 80 degrees, somewhere in that range, all year round, 80 degrees. Now, what this heat pump here will do is it will, because you have this pipe filled with 80-degree water, this heat pump can take the heat out of the pipe or put the heat back in the pipe the same way that window AC did. But instead of having to deal with temperature outside that could be 10 degrees, it's getting constant 80-degree water, which makes it a lot easier to take heat out and makes it very energy efficient. So this is what most new construction in cold places are doing. In warmer places, again, like Florida, Texas, even DC, sort of on the borderline, you tend to see air source heat pumps because you don't have to then heat this or maintain this 80-degree water pipe. But in cold places, in almost all new construction, this is what you're seeing. And then this pipe is heated with essentially like a boiler, like a gas boiler or an oil boiler, mostly a gas boiler. But because you only need to get the water temperature to 80 degrees versus a building in New York City that's just heating off of a water pipe, a hydronic system might have to heat it to 160 or 180 degrees, you use a lot less fossil fuel. This is the state of the art for energy efficient heating and cooling. Single pipe heat pump, tenant has full control. They can go into heating or cooling mode. And all you have to do is use chillers, which are electric, or a small gas fired boiler to maintain this 80-degree pipe. Anybody have any questions on this so far?
Well, I think you just mentioned the question I was going to have. You have to heat that water to 80 degrees to circulate it in the winter. So during the summer, you're actually rejecting heat out of that loop.
Correct.
So that you keep it at 80, right? But then in the winter months, you have to heat that water up to 80. And typically the water source heat pump systems we have in our buildings are heated by gas. So we still have a gas component to the equation. So one of the questions I was trying to ask at the Better Building Summit too was like, is there a different solution to heat the water up to 80? Like, is there some kind of heat pump that heats it to 80? And then I don't know. It just seems like
it's the question. So you're already in a pretty good situation where instead of using, I'm just making up a number, $500,000 worth of gas, and you're using maybe $300,000 of electric and $100,000 of gas. I'm making up numbers here by using essentially like water source heat pumps. You're asking how do we take it to the next level, which is like not burning the gas at all. And the answer is there are air source heat pumps. If we go back to essentially my diagram, there's a giant version of this that goes in the basement and will heat water to 80 degrees and use the air. It is, again, very energy efficient when it's very cold outside to do that and extremely costly. So the other thing I want to talk about in terms of, so this is new construction, right? You can retrofit buildings into, especially if you have a hydronic system. So if you already have a water pipe that's being used to heat the building, you are in a much better position to move towards water source heat pumps in the units like Bob is talking about and like what I was showing over here. The problem is, and this is the last big gotcha in retrofitting buildings, most buildings that were built prior to 20 years ago do not have enough electrical capacity at the building level or in the unit level to run these heat pumps. So this is a major issue that you're seeing in many buildings. I live in a 500 unit Upper West Side building. It's a hydronic system. We have a water pipe that goes to every building. We heat it to 160, 180 degrees during the winter. Fan that runs and blows air past that pipe to heat the apartments. I looked at, could we replace that fan unit with a heat pump and heat that pipe to 80 degrees? And it would have cost us $16 million to rewire the electric in the entire building to do this. So it's a real challenge, and this is why you haven't seen a ton of retrofits to electrification. Where does this basically leave people? So I think the basic answer is if you have hydronic and you're on oil and you have enough electric capacity, I would absolutely bring somebody in. Block Power does it. There are other companies that do it. Have them do an audit and see if when your boiler breaks and you need to replace it, can you replace it with, a downsized boiler and heat pumps in unit. Con Ed has rebates for this that will help a little bit. That is a great path. If you're on a steam system or you don't have enough electrical capacity, it is very hard to move to electric in an economically efficient way. You can do it, but you're generally going to have a pretty negative ROI. What really needs to happen is, and I do believe it will happen over the next 20 years, is we need the electric grid to move to renewables so that the cost of electric and the carbon profile of electric drops significantly. And I actually think you're seeing this happen slowly. And it's one of these things. Has anybody heard of Moore's Law? Anybody know what Moore's Law is? So Gordon Moore was the founder of Intel, and he observed this fascinating phenomenon that basically every 12 to 18 months, the speed of the microprocessors that Intel was producing would double. And basically, when you look at all technological progress over the last 40 years, it's on this pretty like mathematical curve that looks like this. Some things like the cost, like computing power, you're like probably at this area over here, right? Like every year it's doubling and it's like getting a lot faster very, very quickly. Storage, hard drive storage, speed of the internet might be over here, right? But like you're on this part of the curve. There are other things that are really at like this part of the curve, haven't really gotten started yet. And this is sort of where technology is going to have an impact on energy. I firmly believe you're going to see things in nuclear, in renewables that are going to take us from this part of the curve to this part of the curve over the next 20 or 30 years. As that happens, the cost of electricity will drop 80, 90, 95%. And when that happens, it'll be so economically efficient to move to electrification that it'll be worth the capital expense for buildings that are on steam or don't have the electrical capacity to move. In the meantime, my best recommendation for running an energy efficient building is make sure you're on gas. And when your boiler breaks, really try to downsize the boiler to run a more efficient, smaller boiler. There are a couple engineers in the city that are really great at this. The gentleman named Ralph Germain does a lot of the upgrades in buildings. He's awesome. If your boiler breaks, he's the best to come in and say, like, this is how I'd save energy. And then obviously, if you are running any type of central system, you want to have smart controls on there. About 25% of the energy is wasted on running the system unintelligently off of the outdoor weather. So no matter what you do, if you have central systems, you want to basically be monitoring that. But that's a general ballpark summary of my recommendations. I do believe over the next 20 years, you will see cost of energy, electricity drop significantly. And as that happens, I think electrification in colder areas will become more, economically viable. Yeah, go for it, Bob.
It's been suggested that we're a gas heated building with steam,
Yep.
1928. It's been suggested that we might consider moving heat pumps, domestic hot water to heat pumps and leave the rest on gas. But from what you're telling us, that's probably not the way to go. We just did an upgrade, a new control system on the boilers themselves, which are very old, 15 years, 20 years old.
Yep.
So, but it sounds to me, there are two issues for us. One, there are several issues, but the key one is that we actually don't think there's a heat pump that can provide the hot water. And so what I was hoping to hear from you from this call was, are there heat pumps? Because we'd have to put like 20, 50 in the basement to provide that for domestic hot water. Is there a feasible heat pump for that or not?
There is. I mean, I don't know the specifics of your specific building and size but generally there are heat pumps that will do hot water. It is very dependent on your specific system, on how efficient the boiler is running, the patterns of how it runs, how the building is piped, et cetera, whether or not that's going to be energy efficient. In many cases, it's not. The benefit of splitting the hot water out, both with a heat pump or with just gas-fired hot water heaters, is that during the summer, when you're running this, you don't have to run these gigantic boilers and bring them to pressure just to provide hot water. You can just run these smaller, either gas-fired, like hot water heaters or a heat pump. And when it's hot outside, it's a lot easier to do that, and it's very energy efficient. So it really is a very bespoke analysis. In most cases that I've seen it, it's sort of borderline. Like you're probably going to save money with a gas-fired heater. But if you want to be ahead of the trend, I wouldn't say don't do it. If it's a negligible difference, 5 or 10%, you may be better off moving to the heat pump just to be more future-proof long-term.
Okay, thank you.
Tim, do you have your hand raised for a question?
No, my hand's not raised. Sorry, it's probably from
Oh,
before.
no problem. Christine,
All
go
right.
ahead. Christine, do you have a question? If you're talking, you're on mute, Christine.
Hi, no, that wasn't me. I don't have a question.
Okay. Colette?
Yes, I have a question. We have a new construction building that has a water source heat pump,
Yep.
but we continue to have ongoing problems with the P-tax in the units.
Hmm.
I don't know if it's a problem with the chiller or what exactly the problem is, but are you finding that if you have a P-tax system that has a water source heat pump, is that problematic?
What problems are you having specifically?
People are not getting heat or air conditioning in their unit through the P-tax.
So they turn it on and it's just blowing cold air in the winter, and it's blowing just warm
It's
air.
not blowing anything right
Oh,
now,
the fans don't work at all.
as far as I know. That's the
That's very
situation.
you should definitely have an engineer look at that. That seems very strange, and there are a lot of. I mean, again, new construction can be built really well or really badly, right? As you probably well know. So it is entirely possible anything is going on there, but there are many buildings that are running off of water source heat pumps and work flawlessly. So if it's not happening in your building, you absolutely should go back to the engineering firm who did the heat pump design or installation. And I don't know how new the building is, but like there should be a reasonable warranty on those heat pumps, and ask them what the heck is going on, because that's not.
That's not normal. You seem to feel they should work
They
flawlessly,
should be
but
working. With a water source system, they should be working without a problem, especially new construction.
okay, thank you.
Alan, go ahead.
Yeah, Lee, your presentation was clear, but to me, there's one thing missing from this, is how all this interfaces with what the New York City energy, building rules are going to be. I think we have standards that are set for 2035, but beyond that, I don't think anything's been said, and how fast the city is going to push, and whether these pushes for electrification come before the grid
Yeah.
and makes it affordable.
So it's a great question. It's building dependent. If you have a very specific question about a building and you email our 24/7 support, like somebody can do an analysis on your building. But for the vast majority of buildings, if you do bread and butter stuff, you have smart controls like Runwise in, you have insulation and venting, you have LED light bulbs, and you've done the harder work, which is just going into the units, making sure the radiator valves are open, making sure that like you've taken out the window ACs or you have proper cover, like things that are just the bread and butter. That will get most buildings definitely through 2025 in almost all cases, and in many cases will get them through 2030. Sometimes you may need one additional capital project, like if you have absorbers for your chillers or something, like you might want to like replace those with new electric absorbers, which are much more efficient. Sorry, I apologize. But generally for most buildings, you're clear through 2030 with, bread and butter and maybe one capital project. As you get to 2035, 2040, it's a little bit more complex. And my gut says that it's going to be very hard for the city to require electrification until the economics make even remote sense, and or we've moved to a more steady grid, because even just getting a new Con Ed vault built for a building to supply the electric needed for electrification requires takes Con Ed a year or two to do it. And if you went to Con Ed and said, okay, there's 50,000 buildings in New York City, in the next 3 years, you need to put a new vault in every single build. I mean, they would never be able to do it, right? So I think it's going to be very hard for them to make that a requirement until there's a substantive change in the way the grid operates. So I think through 2035, you're probably in pretty good shape. And my hope is by 2035, we start seeing substantial changes in the energy cost, where that energy comes from, and hopefully the technology for heat pumps and retrofitting gets a lot better as well by then. Does that answer the question, Alan?
Um, yeah, I mean,
Ish.
I understand the problem, but it's just a mystery as to what's going to happen after 2030. I suspect you're right, that it's pretty unrealistic to demand of buildings that to install stuff at impossible rate of cost without heavy subsidies coming from somewhere. So
Also, the electric grid just could not handle
right,
all
right,
day.
right.
I mean, you would need. We did our back of the envelope on it, but the electric grid would need to more than triple or quadruple in capacity in order to support full electrification for all buildings in New York City. Which again is just like, I don't see that happening without a substantive change in the source of electricity.
Right. I mean, I think the real problem is at the moment would be for buildings that are facing replacement of boilers within the next 10 years and
Yep.
putting up a big capital output and and then having to have another one
Yep.
shortly thereafter.
No, it is. I mean, again, my general advice is it's very hard to look beyond 5 to 10 years with this stuff based on energy prices and a lot of other things. So if you can reduce your budget, your energy costs by 25% by downsizing your boilers, another 25% by putting in better controls and just doing better and better stuff, even if in 10, 15, 20 years you have to do another major capital upgrade, you're going to have a lot more money in the budget every year you're saving from the reduction in energy. So, in where possible, I just say save as much money as you can, like keep that money, maintain a healthy reserve, knowing that there are more capital upgrades coming down the road. And that's probably your best bet right now because it's just really impossible to predict the future.
Can I ask an unrelated question from
Absolutely.
earlier in the presentation?
Sure.
We're a building that has a problem of return line leaks. We've had it for years, and these are, we recently had one leak discovered under an apartment. They had to dig up quite a bit of the floor to replace it. The problem is discovering where these leaks are when they're buried under layers of concrete and dirt, let's say in the basement or under the dirt underneath ground floor apartments that are not accessible.
Yep.
And heat guns don't help, and I just don't know if there's any non-invasive solution. You can't start digging up our entire basement and everybody floor to find these things.
You are asking the $1 million question. Just to give everybody else who's on the call some context what we're talking about. So if you have particularly a steam system, right, you have water in the boiler that's being that's being heated to create steam. That steam goes up the riser, comes back down the return line, and in many buildings, particularly older buildings, there are leaks in that return line, and so hot water is spilling out, often underground, and you don't know about it. And so you have to constantly feed new cold water from the city. This is really bad because A, you're paying for that water. B, you're taking ice cold water that has to be reheated, which means you're paying a lot more in energy costs. And C, because you're going from hot to cold, you're stretching the tubes of the boiler, which reduces the lifespan of the boiler. So it's just a triple whammy on bad stuff.
I mean, Lee, just let me add, there's another problem is your water in your boiler is treated with chemicals to prevent corrosion. if you're replacing half of that water with fresh water because of return line leaks every time, and not replenishing the chemicals or have some other solution to prevent the corrosion, you're really hurting your boiler.
Yep, that's a great fourth one. So just bad news all around. Most buildings have no idea this is even happening for years and years. They're just energy bills going up. If you have Runwise installed, we install a meter on the feeder from the city so that you can at least see how much new water is going in, which is equal to the water going out. And this is a graph showing you a building that just has a massive return line leak. And you can see at the beginning of the day, we start at 0 again. And then quickly by the end of the day, you're at 2,000 gallons of water. So it's just really bad. And what Alan is bringing up is the challenge of that. These pipes are buried underground and the water, hot water spilling out. You don't see it, right? It's not like it's on the surface and there's a big flood sometimes, but it's very rare. What do you do? How do you find it? How do you know what's going on? There really is no perfect solution. Again, you've sort of mentioned it, Alan. The flare guns, they're heat guns. The really high-end guns with people who are trained to do it are your best option, where you shine the heat gun at the floor and you try to find where there are pockets of heat, and then you drill into the floor to basically find that pipe and replace the pipe where there's hopefully hot water spilling out. It is not a surefire solution. It's not perfect. I'd say you can fix about 75% of leaks that way with somebody who's really adept at using one of those, but it is not an easy solution. And honestly, we've been thinking about how to technologically solve it and don't have a great answer either. It's really hard. And it's more laborious, honestly, than anything. You just got to really try to use the heat guns and be meticulous across the entire basement to see if there's anywhere that it possibly could be spilling out. I wish I had a better answer for you, Alan. Any other questions or anything else?
Lee, this is Christine. I have a question.
Shoot.
So, the New York City Accelerator told us that we need to do the heat pumps. We currently have heat pumps on a few of our floors, and we have 2 floors that we need to replace the existing AC units just because they're old.
Yeah.
And so, we've gotten proposals to put in the heat pump on 2 floors for, $70,000. And so now, and even the our air conditioning, our HVAC guy said that the heat pumps don't work great under a certain degree, and just like you said, they work better in the south. So now, I'm wondering, should we not put in the heat pumps? Should we wait is longer to see what unfolds? Because I don't want to put the heat pumps in and then it doesn't do us any good.
How big, what type of use case is this, commercial or residential? How big is the
Commercial.
building? Commercial. How big is the building?
6-story building.
6-story. Okay, rather.
It's in Landmark, 1888.
And do you currently have a central heating system?
The boiler.
The boiler. Okay, so
yeah.
is the boiler working sufficiently? Like the spaces are getting sufficient heat, everything is fine, and you have these AC units in the specific spaces, and you're being told like, hey, stop using the boiler and
Correct. Yeah, we use the AC units in the summer and we use the boiler in the winter, but the New York City Accelerator basically wants us to remove our boiler and not use it at all and just use heat pumps on every floor. But that's not going to work for us.
I mean, you have to make the decision individually. I would tell you, I would not remove a working boiler.
No, we're not doing that.
Yeah, I would definitely not do that for sure. My feeling is there are a couple ways you could kind of split the difference. One, I would find out what the cost of just replacing the AC unit is versus putting in a heat pump. Often, like the newer AC units are heat pumps as well, so there's not really that much cost to just you putting the heat pump in, and sort of gives you a backwards control. Also, the other thing is, if you do have these, if you are going to do it in every unit anyway, what you can do is you can run the boiler. So if you have Runwise installed, we can calibrate it to run the base building only when it's cold outside to a certain temperature. So we can say when it's below 40 degrees, we want you to run the boiler to make these spaces get into the 60s. And then what you can do is you can have the heat pumps themselves essentially run to augment that
Yeah.
Which is it's almost like it's called hybrid electrification. That is a really good way of doing it. I certainly would not remove the boiler, as you said. You're not doing that, and I probably would not go and, if you have working AC units that are fairly efficient, go and for no reason replace them with heat pumps.
Hmm.
That's just not going to be a great economic,
Yeah.
proposition. If you already need to replace it because it's broken, or you have one that's extremely inefficient, and you're going to save money moving to it, and you can get heat pump built in, I think that's a worthwhile proposition.
Okay. Thank you.
No problem. Any other questions? Anything else anybody wants to cover? Awesome. We do this every couple of weeks. I'm Lee at Runwise. You can email me anytime. You can email or call our support 24/7, 365, literally at 3 a.m. if you have a question and have Runwise. We're here, and we do this every couple of weeks. So if there are any topics you guys want it covered in the future, by all means, let me know. We'll cover it. And then lastly, I'm on LinkedIn. If you want to add me, Lee Hoffman. I produce a video every week on a different topic that's usually interesting. Last week was on City Steam. We cover just different things, and we put out content every week as well. So if you want to keep up to date in between them, you're welcome to follow me or connect with me on there. Awesome. Thank you, everybody. Really appreciate it. Really appreciate all of you joining today.
Thank you.
Thank you, Lee. Appreciate it.